Good afternoon, everyone. I am in group 14. My name is Jane, and I grouped with Aaron, and our project is called AI-based Flight Planning Agent. So, in short summary, we created an intelligent system that helps travelers find the best flight route between two cities, balancing time, cost, and the number of layovers, while adapting to real-world conditions like weather, delays, or cancellations. So, over the next few minutes, I'm going to talk and then I'm going to toss it over to Aaron, and I'll walk you through what problem we solve and how our agent is designed and how it makes decisions using reasoning and search. So, let's take off and explore how our AI agent thinks like a smart travel planner. So, at its core, our project combines artificial intelligence with travel optimization. The goal is to make flight planning smarter instead of human comparing dozens of flights manually, and the agent analyzes every option automatically. It looks at four main factors: cost, total travel time, layovers, and reliability, and continuously updates its plan when the new data arrives. So, for example, if a storm hits or delay occurs, the agent immediately re-evaluates and adjusts. By applying the artificial intelligence reasoning and search algorithms, the system behaves almost like an expert assistant that never gets tired or confused. So, as you can see, there are so many variables when it comes to traveling, and that made us question now, why do we need such an agent? Because flight planning today is very complex for manual decision making. Every traveler faces mazes and mazes of variables, such as like price changes, connection times, unpredictable weather, and last minute cancellations. So traditional systems handles these factors one at a time, but they cannot react dynamically when the conditions change. So as a result, it causes missed connections, higher costs, and low efficiency routes. So our project solves this by introducing automation plus intelligence, a way for the system itself to recognize new problems and adapt before the traveler even realizes something that went wrong. So our objective is very clear. So designing an AI-based flight planner that automatically selects the best possible route from origin to destination. The agent evaluates flights not just by price or time, but also by real-world conditions, such as airport curfews, weather alerts, or maintenance issues. And it continuously refines its plan using inference and reasoning, so every new piece of information can trigger a smart decision. As summary, our goal is to make travel planning intelligent, flexible, efficient, minimizing time, cost, and hassle-free for the travelers. So as you can see from the screen, this is how our AI agent actually works. It's designed as a model-based reflex agent, which means it does not just react blindly. It keeps an internal model of its environment. That environment includes airports, possible flight routes, external factors like weather and restrictions, and the agent constantly receives percepts or inputs, for example, weather updates, storms, flight delays, or ticket price changes. So, based on those inputs, it performs actions such as picking a flight, waiting, or rerouting. Its goal is always the same: reaching the destination efficiently the best way possible, staying with both budget and time. And the system measures its own performance by minimizing total travel time, total cost, and numbers of connections. So, as summary, our agent doesn't just follow presetted rules. It perceives, reasons, and acts and learns like an intelligent traveler. And now Aaron is going to take over and show you guys how this agent works.
Hi, my name is Aaron, and I will be talking about our knowledge base. First, we start with our environment description. We can see that each city represents a state in the graph, and the edges are flights connected from the cities or possible actions that can be taken. Each flight has three attributes: cost, duration, and availability. The agent starts from an origin city and must reach the destination city. Looking at the facts, we could see a couple examples. If the options are New York, Chicago, Dallas, Los Angeles, and Miami, we can see that flights exist between New York, Chicago, Chicago, Dallas, Dallas, and Los Angeles. Using that, each fact follows this form: source, destination, cost, and duration. On the right side of the graph or the PowerPoint, we can see the percepts or what the agent can read. From these 7 options, we can see the agent can read flight availability, cost, duration, weather, delay, current location, and the user's budget. Using that information, we create our rules or propositional logic for this knowledge base. Rule 1, we check availability. If the available flights equal no, then we mark as flight unavailable. Rule 2, if there is a delay, the flight is unavailable. So if there's a delay, yes, the flight is unavailable. If we go down to 4, we can see weather. If there's a storm, we check the duration, the effective time, and then we multiply it by 1.3, which is the delay that is caused to the flight. From this, we can see on the right side the path and goal reasoning. For example, at rule B2, if the cost so far exceeds user's budget, we are at an invalid state. But eventually, we will reach rule 3, which is if the agent reaches, in this case, LA, the goal is reached, which the goal was LA. Rule 4, we can see that you can connect one flight to another, creating a possible path. Seeing this, we can now see how the agent would think from the knowledge base. Now we can look at the a state space graph of this information. We first get an initial state, which is the start city, and a goal state, a destination state city with chosen restrictions. The restrictions can include airport curfew, weather, max connections, total costs, and a deadline. For this example, we're just going to use total cost and total time as our chosen restrictions. So in the in this graph, the state is defined as a current city, total cost, and total time. And here's our state space graph. The start city is New York at 8 o'clock. Our goal is to reach LA in a budget under or around 400. Here it is. The goal, find the best path from, in this case, New York to LA, considering cost and travel time. At New York, destination Los Angeles, budget 400. Looking at the graph, we can see that many or 3 fit the requirements. So looking at that, we can see that 1430 is the earliest time, making it the best choice in this particular case. We made sure to follow these rules. We made sure the cities were connected to form possible actions. The flights were within budget, and if this case mattered, we made sure that the duration was under the max time needed. We made sure that the flights combines to form a valid path. Using forward chaining, we found that this New York to Chicago to LA was the best choice for this case. Overall, with this information, we can demonstrate that an intelligent agent can make rational travel decisions using a structured knowledge base and logical inference by defining possible states, actions, and rules in the logic. The agent can also use reasoning through constraints like availability, cost, weather, to find the best possible route to a destination. This process highlights the importance of knowledge representation and inference in AI, allowing the system to not just store information, but to draw meaningful conclusions. In the future, this model can be expanded by adding more restrictions and integrating real-time flight data like flight delays, pricing, or user preference. Thank you for watching our presentation.